Okay, number 8 says to solve this system using elimination. So I'm going to make sure that I use that method and not try substitution. I know that for elimination, I have to have either the coefficients for the x being the same number and different signs, or the coefficients for the y being the same number and different signs. So you want to step back and think about which one might be less work. So what I would notice is, yeah, the signs are what they need to be for the y's, but if I look at the x's, I have coefficients of 1 and 3. So guys, it's going to be pretty quick for me to just change this top equation. If I multiply this top equation by -3, I'm going to have the x's being exactly what I want them to be, +3 and -3. If you went for the y's, like, yeah, the signs are good, but you'd have to multiply both equations to make them both 10. And that seems like more work to me. So I'm just going to distribute -3 through to the top equation. So be really careful, multiply every term. So -3 times 1 is -3x. -3 times -2 is +6y equals -3 times 16 is -48. Okay, now I'm going to ignore that top equation and I'm going to eliminate or add to eliminate for these two equations. So 3 plus -3, that's 0 x's, those eliminate. Cross them off. 5 plus 6y is 11 y's. Bring down your equals. And then 15 plus -48 is -33. Be really careful with your signs, you guys. One little sign messes everything up. So divide by 11, and y is going to equal -3. So that worked out pretty nicely. Now I'm going to bring my y up. I can start my answer. I know that y is -3. Remember, it's x first, then y. So y is -3. I'm going to pick one of these equations to plug it into. I'm actually going to pick the first one. Even though I crossed it off, I can go to that one. I like that one better. The numbers are smaller. Let's see, so if it helps me, let me erase all that. So I'm going to plug it in right here. Maybe let's do the work over here. So x minus 2y equals 16. It's pretty plain. I like that. I know that y is, -3. So I'm going to plug that in where y was and use parentheses when you plug it in. That just means multiplying there. So be careful with your signs here. I'm going to do -2 times -3, which is +6. Okay, then x equals 16. Be careful with that multiplying. And then I'm just going to subtract that 6 over, and I have x by itself. So x is 10. So my answer is 10, -3. All right, on to the next page, number 9 here. And 9 and 10, the directions both say solve using any method. So substitution or elimination, I need to decide which one is more convenient. And do not make this worse than it's supposed to be, guys. Number 9, this is set up perfectly for substitution because you have y all by itself in that second equation. So I'm going to use substitution. That's going to make my life a little bit easier here. So y is the same thing as -4x plus 10. So I'm going to come to the top equation. I'm going to remove y, and I'm going to substitute in its place -4x plus 10. So I'm going to rewrite that top equation, 8x plus 2, and instead of sitting next to a y, I'm going to put in its place, in parentheses, -4x plus 10, and then equals 20. I don't like how sloppy that plus sign is. Sorry. Okay, so that's plus 2. So now I can solve that equation for x. I have an equation that just has x's, so that's pretty easy for me to solve. So I'm going to distribute first always, and that will look like 8x plus no, not plus, negative 2, or 2 times negative 4 is negative 8, sorry, x's. 2 times 10 is 20, equals 20. Oh, this is nice. Okay, now look what happens when I put the x's together. 8x minus 8x, that's 0 x's. Those eliminate. So that's gone. So I look at what's left. It's 20 equals 20. Okay, when the x's or the y's cancel out, it's one of the special cases, either infinite or no solution. So I look at what's left. That's true. 20 does equal 20. If it's true, that's infinite solutions. If it would have been something that was false, like 2 equals 20, that's no solution. All right, infinite solutions on that one. All right, the next one, number 10, again, it says solve using any method. And if I step back and look at this one, you guys, this one's set up perfectly for elimination because I see that the x's, the coefficients are 12 and negative 12, which is exactly what I want. So I'm going to choose to do elimination on this one. It's set up, it's ready to go. So I'm going to add the two equations together. The x's will eliminate. That's 0 x's. So now the y's, 10 plus 9 is 19y. Bring down your equals. 12 plus 102 is going to be 114. So now it's a pretty simple one-step equation. I'm going to divide by 19, and y ends up being 6. Okay, so that worked out nicely. I have the y value is 6. So now I just need to bring that back up to the top and plug it into one of those equations to find x. I'm going to use the top equation. I just feel like 102. I would like to avoid that if I can. So I'm going to go for this equation. We know that y is 6. So I'm going to take y out, and I'm going to plug 6 in its place. And now I'm just going to solve that for x. So 12x, let's see, 10 times 6, that's 60, equals 12. Now I subtract the 60 over. Be careful just with your adding and subtracting. Do not make a small mistakes here. So that's 12x equals negative 48. And then you're going to divide by 12. And negative 48 divided by 12, x is going to equal negative 4. All right, so my answer is the ordered pair negative 4, 6. Okay, last question now is number 11. All right, let's kind of get this on screen. Here we go. So number 11, it's the second word problem that we see. It's Roger and Junior again, same old guys. And it says Roger and Junior went to 2 baseball games this past weekend. Okay, that's not really super relevant. Like, don't use that 2 for anything. I guess it's good to know we got 2 different games, but that 2, not part of the problem. Distracting information there. So I'm going to cross it off and read the rest of it. It says, at the first game, they bought 5 hot dogs, 2 orders of nachos, and spent $13.75. At the second game, they bought 4 hot dogs, 3 orders of nachos, and spent $14.50. What's the price of each food item? Okay, you guys, if you look, we've kind of helped you out here, and the answers, I've got hot dogs and nachos. So, okay, that kind of makes picking out my variables a lot easier. H and N is what I'm going to use. Your system, your 2 equations are going to come from those 2 different baseball games. So the first baseball game, let's see, I did all that information in purple. So I'm going to write that first. It's 5 hot dogs plus 2 orders of nachos, and they spent $13.75. This is not my favorite that there's decimals in here with all the money, but that's okay. We can use calculators. You should use a calculator. This is going to be tough without one. The second equation is going to come from the second baseball game. So that was 4 hot dogs plus 3 orders of nachos. And that game, their food total was $14.50. So there's my 2 equations. This is definitely going to be better for elimination. I don't have a plain variable that's just like just h or just n. So I'm going to go for elimination. And guys, I'm going to have to change both of the equations, which is kind of annoying, but that's okay. I'm going to take my time. I'm going to go for getting the n's the same just because the numbers are smaller, like 2 and 3 as opposed to 5 and 4. So 2 times 3 is 6. I'm going to aim to make both of these a 6. So 2n, I know I need to multiply that by a 3 to make that 6. The second equation, the n's are 3, so I'm going to multiply that by 2 to make that a 6. So now this is going to give me both 6 n's, but I want one of them to be negative. So I'm just going to take that top equation and make it a negative 3 that I distribute. Okay, be super careful. Use your calculator. Negative 3 times 5 is negative 15h. Negative 3 times 2 is negative 6n equals negative 3 times 1375. This is what I'm talking about. Be really, really careful with your calculations. It's really important in math that you get everything correctly, all these numbers, but it's negative 41 and 25 cents. Okay, second equation, I'm going to distribute the 2. So 2 times 4 is 8h. 2 times 3 is plus 6n equals 2 times 1450 is 29. All right, now I'm going to add these together. I'm going to kind of like ignore those original equations for now and add my new ones together. Again, be careful. Negative 15 plus 8 is negative 7h. Your n's eliminate. Negative 6 plus 6 is 0. Those are gone. Bring down your equal sign. Negative 41.25 plus 29. Again, be very careful. This is like, there's a lot of room for error here, but that's negative 12.25. Okay, now I have a relatively simple one-step equation here. I'm going to divide both sides by negative 7. Guys, this should work out to be a number that makes sense. You're talking about like how much items cost at a baseball game. You can't say like negative 1.5. They're not going to pay you to eat a hot dog at this game. It should be a positive number. And I know mine's going to be because it's negative divided by a negative. So when I put that in my calculator, h equals, this is 1.75. That makes sense. That's how much the hot dog costs, $1.75. Okay, let me erase some of this here. I'm going to take that answer, and I could plug it into any of the equations, like the new ones or the old ones. The old ones are going to be a little bit nicer, in my opinion, because the numbers are smaller. Okay, so check it out. Here's my h value. I'm going to bring that back up. I'm going to pick one of these to plug it into. I'm just going to go to this first equation because it's like relatively simpler. So let's just recopy it. This is what it was. We know that h is $1.75. So I'm going to take h out and put in its place $1.75. So I'm going to multiply 5 times $1.75. That's $8.75 plus 2n equals $13.75. Now I'm going to solve that. Oopsie. Okay, sorry. 8.75. Okay, so I'm going to subtract over 8.75. Ooh, these numbers are not our friends. That's okay. So then that's 2n equals 5. That worked out a little bit nicer. And then your last step, divide by 2. So n is going to equal, 5 divided by 2 is $2.50. $2.50 for nachos. That makes sense. All right, I hope this was helpful, and I hope you guys feel more prepared for solving systems to do a lot better on your retake test.